Okay, how's the audio? Mic check, mic check. Good, looks good, looks good. Okay. Let's see if we can get a text document onto space recipe. Go Brit 31, 34, 36. Custer 16, barium 4, DK 26, silica 17, bentonite 1. A little bit big. Line blend time. It is. Yep. You guys are gonna get to see the full shebang. I'm just inputting my recipe here. And next, I'm gonna go ahead and multiply it out by 12. So text, properties, I think the maximum percentages will be somewhere with mason stains. I think they'll be maximum about 10%, 12%, something like that. And then minimum percents will be 2%. I don't know. I'll go through my box of mason stains and sort of choose. I'll talk about the colors that I've experimented with before. What color do you think? Got any suggestions? Okay, 37 times 12 equals 440 grams. Okay, next, 16 times 12 is 192 grams. Oh. Okay, 4 times 12 is 48 grams. Wait, no. Yeah, 4 times 12, 48. 26 times 12, 312. 17 times 12, 204. Really, a lot of the times you're right that you kind of do know what you're going to get. But in glazes, it's really, there's no substituting for just seeing what they look like. Just trying the recipe and seeing. Every base glaze is different. And the way that the glazes melt and look over clay, there's always just so much variation. Okay, and then one more, we got Bentonite. It's 12 grams. Okay. Reckon we could probably zoom in a little bit. Yeah. Okay. That looks good. So then, what are you surprised about? Tell me more. Okay, and then I'm gonna jot down my notes here. You can see I always keep a little scratch pad of what's going on. So many times just taking notes on a little scratch piece of paper has saved my buns in tracking back what I did in the Glaze lab. 312, 204, 12 grams. Yeah, 100%. Okay, and then the tare weight of our bucket is 158 grams. It's going to come in handy. Tare weight of the bowl is 267. That might come in handy too. So we're just going to really quickly yeah. All right. I'm picking up what you're laying down. Okay. So if you didn't catch me mixing the sapphire blue base recipe, you're in luck, because I am going to right now mix up a base glaze. And so what we're gonna do here is I've got these 12 empty cups, and rather than mix the base glaze for each individual cup, I'm gonna mix it in a bucket and do basically 12 cups worth of glaze all at once. And then I'm going to divide that out evenly into the 12 cups, and then I'm going to go through and into each individual cup I'm going to add a colorant, okay? And I haven't decided which colorant, and I'm probably going to think about that while I'm mixing the glaze. So we're going to do a glaze mixing speed run here. We're going to see how quick I can do this. And if you're curious what glaze I'm mixing, I've got my glaze recipe on the screen there. Okay, and because this has some barium in it, which is a not so friendly material, it's actually a heavy metal. It can cause poisoning in high doses. But poison is in the dose. You can be poisoned by water if you drink enough of it. So here we go. First ingredient, frit number 3134. Oh wait, I'm already forgetting. The most important ingredient to start with, and that's the water. And we're gonna take 1200. Hey, what's up, Raman? Okay, 1200 times 0.7 equals 840 grams of water. Okay, great. Okay, so that's 875, 840. There we go. Next we have Frit 3134, and we need 440 grams. Faro Frit 3134. Okay, 440. Next, I'm going to add in the bentonite and mix in the bentonite with that. And we need 10 grams of bentonite, 12 grams of bentonite. Man, I'm glad I wrote this down and I'm looking at it right in front of me. 3, 5 grams. You have to be real careful when you're adding one material into another to not go too much, because it's really hard once you've already added it to subtract. Okay, 12% bentonite. Now I'm going to go ahead and add in my EPK, skipping over the Custer and the barium for the moment. So let's go EPK, 312 grams. There's 300, 305, 310, 312. Okay, now we're going to add in our Custer. We need 192. There's 100, 160, 170, 180, 188, 192. Let's see. Where is my barium? German barium carbonate. Okay. I need 48 grams. There's 30, 35, 38. Okay, so there's 48 grams. So in this bucket we have Frit 3134, Custer Feldspar, barium carbonate, EPK. Now all we need is the silica, because we've also already added the bentonite. And we need how much silica? We need 204 grams of silica. Okay, 204. Oh no, I didn't tear the scale. So we'll need to add 204 plus 48. 204 plus 48 equals 252. Okay, I'm going to 252. Here we go, 252. Okay, so that's actually, I usually don't do it this way. I usually don't add all of my dry materials into the dish. I like to add them one at a time, but since this really isn't a glaze mixing, I'm more interested in getting them into the cups as quick as possible. I'm kind of working quickly, but what I am going to do is take the time to kind of blend these ingredients together. And then, so as not to kick up a bunch of dust, I'm going to slowly add these in. Okay.
Well, here we are, back in the hot, muggy streets of New York.
If I just flip this bucket over and just dump it in, I get a big poof of dust. Okay, I'm gonna let that soak in. Do I glaze the inside differently on the barium pieces? No. Even though it has barium in it, it is well, very, very well within safety tolerance. The sapphire base glaze is like a shop glaze the world over. It's been tested very many times. I've never tested it personally for food safety issues, but 4% barium. Barium is actually a very safe flux. Barium carbonate especially. All right. Because what ends up happening with these really gnarly materials, you know, stuff like cobalt. Like, how is it that cobalt, which by itself does not take very much to kill you,
I don't know.
how is it that cobalt is in just like every glaze ever? Every blue glaze ever? Well, it's because that those molecules of cobalt bond with the silica, and the silica encapsulates those molecules, right? They form new compounds, new metallic compounds that don't leach, right? So what goes in is not what comes out. It's very much like baking a cookie, you know? Once it's baked, you can't pull the flour out. Okay, so this is looking good. And then this is something that I've talked about before on stream. And this is a whisk, right? It looks like it's a whisk out of somebody's cake mixer. I bought this at the Salvation Army. It cost me 25 cents to buy this. Now watch this move. If you've never put these two pieces together, electric drill, cordless drill, whisk, boom. Glaze Mixer 5000. Look how good that does. Thing of beauty. So having a whisk on your drill is going to make your glaze mixing job a million times easier. And also, it's an added step that I usually don't take, but mixing together all of your dry ingredients and sort of stirring them together, what happens is all the clay particles get distributed with all the non-clay particles, and it just makes the whole thing mix together really well. But I don't know if you can see towards the bottom of this bucket, if the camera can focus in on that. You see those chunks down at the bottom, at the top? Those chunks that are left over? That's what I don't want, because usually what those chunks are the flux chunks. And when you're working in small test batch kind of recipes, when you're working at 100-gram scale, not blending in all those little chunks of flux can really cause you problems. It'll give you a different effect. So what I'm going to do is I'm actually going to sieve this glaze, okay? And this is called a sieve for 5-gallon buckets. If you remember, we had a larger one that fits into my 5-gallon bucket. And these are great. These aren't for ceramics specifically, these are for gold panning. But I bought these and I use them in my ceramic studio all the time. I use the really fine mesh for mixing glazes. And I think I got the whole set of like 8 of these for, I don't know, like 60 bucks. Whereas a really fancy ceramic, a talisman glaze sieve, those things are like 50 bucks each. So I got those linked on my Amazon thing, on my Twitch stream, down below in the Twitch description. And then I think too on my blog, I've got those sieves. Those are, yeah, they're pretty essential. Glaze lab materials. I think if you want to have a glaze lab and mix your own glazes, you definitely need a scale, right? I've got this digital scale, so you definitely need a scale. Definitely need some buckets of various sizes, right? 5-gallon buckets, little, what is this? 4-liter, 5-liter bucket. It's not necessary, but one of these metal scoops is nice. A large mixer, a small mixer, a drill. You can get around that, and you can use one of these little immersion blenders, like the kitchen one. And then you need a sieve, right? And this is a sieve that I made. I just glued in some mesh. I went to the hardware store and bought this 3-inch to 2-inch reducer, this black PVC. And then I got the 3-inch or the 2-inch PVC pipe that fits into that, right? And then basically this inner ring fits inside of that, and it holds in that screen. See if it'll focus in. Not sure the light. There you go. So you can see how that inner ring fits inside of the outer coupling, and it pinches in that screen in there. You can make yourself a little sieve for $20. Or you could just buy one from a ceramic supplier. But this is a pretty coarse mesh. We don't need to be super duper fancy. We're not making rocket appliances. And I just want to pass all this heavy stuff. You can see at the bottom of my bucket, I've got a sludge going on, right? That's all the good stuff. Like when you're cooking soup and you got a pot that simmers for a few hours and all the heavy stuff, all the spices sink down to the bottom. We want to get all that good stuff dispersed and into our glaze. And really, at this stage, I want to minimize or I want to maximize, rather. I want to get as much of the ingredients, the dry ingredients, through. At this point, the amount of water is sort of relative, but the dry materials that are suspended in that water are not relative. That's a very finite. The closer I am to that recipe, the more accurate my test results are going to be when I test this glaze. So another way to say that is it's okay to add water to get every little last bit of material through the sieve. And what I don't want to do is just like spill any of this, because then it's just going to throw off my proportion. Then I won't be able to recreate results. So that goes to say that if you're not trying to recreate, then you can go nuts and you can just dump a bunch of stuff into a bucket and put it in the kiln and fire it. Like, that can be a really amazing way to come up with really cool stuff. There are some artists that like working that way, and that's great, but I tend to try and quantify as much of my glazing efforts as I can, right? I want to recreate or be able to achieve effects that I really like and get rid of the ones that I don't. Okay, so we've mixed up 1,200 grams of our glaze right here, right? And now we're gonna go through and divide this into these 12 individual cups. Okay, I just read your message, Grew the Wanderer. You could make a maximum fluffy omelet with the drill whisk. Maximum fluffiness. Okay, here's a number I'm gonna write down. 2,228 grams. That's what this bowl weighs with all the glaze inside of it. So the first thing I'm gonna do is take 2,228 and subtract the weight of the bowl. And that's going to give me 1,961 grams. So let's go to our recipe. Okay. And that yields 1,961 grams. Okay. Now we need to divide that into the 12 cups. 1,961. Okay, so that means 163.41. By 12 cups equals here's my number, 163.41 grams per cup. Okay, you guys following so far? Any questions at this point? Now, I should say at this point, there's nothing different. There should be theoretically no difference between what I've got in here after I put 163 grams, 163.4 grams into each one of these cups. That's going to be no different than if I was to take our original base recipe, right up in the corner, okay, this recipe right here. If I was to take the base recipe, which adds up to 100, if I was to weigh it out and add it into each one of these, and then add water into each one of these, I'm going to end up with 163 grams in each cup. But I'm saving myself, I'm doing this 12 times faster by mixing it all together, all right? Which is how I used to do it, actually. I used to go and, if I was doing colorants, testing colorants and celadons, I would just go through and weigh out all of my silica and all my EPK, and I would add it into each cup, and then I would add in my colorants. Which is why I have in my lifetime spent thousands of hours in the Glaze lab. Alright, so what I like to do to make this a little bit quicker, a little bit easier, is to weigh out the first one. And we're going to go back to our soup analogy. I want to keep mixing this up. Why? Because I don't want all the good stuff to sink down to the bottom. All right, so I'm going to go to my first one. Bend my bowl a little bit. Okay, so that's 166, 164, 161, 162. All right. 164. Now, what I like to do is to just make a mental note of the height of the glaze. Like how much glaze volumetrically is 163 grams. And I can see that it's about, I don't know, 2 centimeters above that line. So that's just going to give me a reference and help me to divide this out into all these cups kind of quickly. So I'll go up, and I'm messing up here. It's not good to spill any of this. So I'm going to stop doing that. Okay. Try that again. Ah. This bowl is not working. I'm gonna have to do something different here. Okay, so I'll go ahead and break out this tool right here. This is a graduated syringe. And at this point, basically 1 cubic centimeter on this syringe, right? 1 cc is gonna be about 1.5 grams of glaze. And just to make this nice and slippery, I'm gonna put some soap on it. After years of using these graduated cylinders, the clay particles kind of scratch it up and make it not so slippery. Okay, so back to the task at hand. Now I'm gonna start getting scientific and systematic about it, which is what I should have done earlier. But it's not the end of the world. this graduated cylinder is also how we're gonna blend these two glazes together. So, for example, if I've got 1 cup of blue and 1 cup of green, I could take 10 cc's of blue, mix it with 10 cc's of green, and end up with 20 cc's of blue-green. Does that make sense? On that same note, I could take 15 cc's of blue and mix it with 5 cc's of green and end up with a blend of mostly bluish green. Flip that, do 15 cc's of green and 5 cc's of blue, and I could end up with mostly greenish blue. So at that point, having said that, I think you can start to imagine how you could come up with a million different glazes and glaze combinations using a graduated cylinder. You could go into your studio and just start pulling out glaze that's already mixed up and mixing it together, and you just write down your recipe. It's all relative, nothing has to add up to 100. As long as you write down what you've mixed. It can be proportions, 1 part blue, 2 parts green. 1 cup to 1 cup. If you don't have a graduated cylinder, you could just use a scale like this. 50 grams of blue, 50 grams green. You know, measurements and recipes, they're relative. They're usually expressed as 100 so that people can look at it and just off very shorthand they can see, okay, they can look at the sapphire recipe that we've got up there and they could say, okay, you got 37% frit and you got 17% silica, right? It's just kind of an easier way, and it's easy to multiply it out when it's expressed as totaling 100. Okay, we're filling up our cups. So what colors do you guys want to see? I know I'm excited to try a orange mason stain. I've probably got most colors possible. And we can even try some oxides if there's a color that we don't know. Any color requests? Throw it out. What do you got? What do you want to see? Otherwise, I'm just gonna do what I want to do, which is a couple that are orange. We'll try a couple orange variations. We'll try a couple red. I want to have a nice hot red color in oxidation. It'd be nice like that red. That's coming from copper in a reduction kiln. And I don't have a reduction kiln anymore. Earth Wendy with the request. I can't read it. What you got? A reddish color. What kind? Be more specific. Like what kind of red we talking? Brick? Brick red? Blood red? Cranberry? Pomegranate? Cherry? Maroon? Mars? Martian red? Rust red? Blood? Did I say blood? So this is going much smoother now that I've pulled out this graduated cylinder. I am getting some chunks. Ooh, Bing Cherry Red. I like it. All right, we'll try a red. Try a deep Bing Cherry Red. Heck yeah. I could go for some Bing cherries right now. I swear that cherries they grow in Washington are freaking huge and amazing. Same with the apples. What is it about Washington and their fruit being freaking huge? Okay, we got red. Anybody else? Got any colors in mind? We've already got the blue. I mean, the base recipe that one of my shop glazes is the blue. It's opacified, so the base recipe has rutile added to it. I mean, we could try one with just the cobalt and without the rutile, and that'll probably be like a nice transparent. Nice watery blue color. Nope. Drill's out of battery. So we're gonna see how much I spilled. So we got 140, 146. That's short. I can fudge it a little bit. But you almost never end up with the theoretical. You always end up with a little glaze left over in the bottom. So 148, 146. Now I need to get all these even. Oh, I've got a little bit more in my syringe too. Okay, we'll go up to 157. 155. Okay, that's not bad. So essentially what I'm missing is 10 grams of glaze. So if I go and pull just the tiniest little bit, I pull 1 gram out of each of these, I should end up the idea is to get exactly the same amount in each cup. If you're not following so far, that's what I'm doing. So I put 163 grams into each cup to begin with, but then I ended up short 10 grams with my last cup. So I'm pulling out 1 gram, give or take, from each cup.
Perform for 1,000 people and you can't be honest with one.
So I want to have 161 grams in each cup. 161, 161. 161. 161. 161. 63. 61. 161. 161. 161. 61. 61 and 161. Sweet. Great. Sin Pass. Dark rich blue. Okay. Little Pink Pony. I want to try some new colors, so they're not all going to be blue. The original base recipe is blue, but I want to try some new colors. So Sin Pass, they don't have to be. I mean, glaze mixing can be as exact or as loose as you want it to be. I like to get it pretty close, you know. I'd say I'd like, with all of my glaze mixing, I strive for about, call it 90% accuracy. I used to strive for like 100%, and I would inevitably end up with, I don't know, 97 or 98% accuracy, but everything took like twice as long. So there's always this balance, this give-take in ceramics of do it one way and sacrifice something else, do it another way and sacrifice a different thing. So what you give up in accuracy, you gain in time, right? And if I could do 50 tests in the same amount of time that it would take me to do 20 tests that are really accurate, I'm going to pick the 50 tests, and who cares if it's not quite exact. Does that make sense? Yeah, so this is 12 base recipes, and then we'll see how much glaze it takes to glaze each bowl. But on stream, we made 50 of these little bowls, and we're gonna glaze them in as many different color glazes as we can. All right, so we've got colors. So I think we're going to go through and divide these. We've got 12 options. So we'll do 6 that are opacified, and then 6 that are straight. Okay, and 1 through 6. 1, 2, 3, 4, 5, 6. Those are going to be opacified. And what does opacify mean? Well, it means not see-through. Okay, so look at this glaze right there. You see how it's really kind of watery and pretty see-through? Right, you see the blue, how you can see the clay underneath it. And then this glaze is not see-through. Okay, so this is the base glaze right here. This is terrible light. Let's see, can we see it better up here? That's a little bit better. I want you guys to actually be able to see this. How about we move the camera real quick to some better light. All right. So there's the blue. There we go. See how it's cloudy? And especially on the bottom where it's just the base glaze. So that's what the clay looks like just by itself. And then this blue, that's opacified. And so rutile is causing that. It's actually titanium that's causing that white, milky kind of color. And that black is caused by a second glaze. There we go. Oh, it focused. Come on, camera, focus for me. Now, here is, it's not the same glaze, but you see how you can see straight through that glaze? Right, and this one had big chunks of other stuff melted in. You see how that almost looks like glass? You know, it's just like a much clearer glass. That's not opacified. So then, here's a glaze combo. This is a glaze that I buy from Seattle Pottery. And it doesn't look like it on screen. It looks like the same color as my glove, but this is a purple. This is like a lavender purple. And then mixed with the blue, there's this piece. So this I can already get in my studio. So I don't have to do a bunch of purple testing. So we'll go ahead and rule out purple, because I've got a pretty killer looking purple right here. And that's the combination. So what do we have for mason stains? We've got some, this is orange. So maybe we'll do an orange. We'll do an opacified orange with 3% rutile and 5% orange. And then we'll do an unopacified with orange. And we'll just do straight up 10% orange mason stain. And this is from American Pigment. It's 1352-0. We've got Canary Yellow mason stain. Got this pack of samples. And these are all their warm colors. Ooh, this lime green might be kind of sweet. 1352 green. Or G. Oh, I guess it's just the letter that they go by. Here's a nice yellow. That's kind of a dandelion. That's more of a canary. Got some other oranges here. These are more of a tangerine. That looks to be our Bing cherry. You can see these are all reds. Ruby, DR, probably dark red. RO, probably red orange. 50672. W. RM. $7.79. I guess some of these are mason stains and some of them are... Oh, let's try the DR because I have a whole bunch of it. That's probably like $60 right there. That bag of red. Can't remember what I paid and when I bought these. Here's some purple that I've got a bunch of. But I'm pretty happy with my purple glaze already. Got lavender mason stain. I've tried this a lot, and it's just never really worked out for me. So that one's not making the cut. Little Pink Pony, you asked if I add red to a blue glaze, will it make purple? Yeah, sometimes. Sometimes it will. Sometimes it won't. That's one of the things that I really like to tell beginning ceramics students is that glazes are not paint. And so you can't just mix white glaze with another glaze and expect an opacified version. Ooh, this one is a really good pink. I could go for a nice pink glaze. We were tying some flies. And I said I wanted to come up with a glaze that looks as hot as these flies. Like these things just look like candy. Yeah, we're gonna try pink. Good night, Ezekiel. Thanks for stopping by. Yeah, alright, little pink pony. You have me inspired. We're gonna try this pink. Alright, so we got orange, red, and pink. Which are all very good fly fishing colors, so why don't we stick with... Oh, here's some tiles. These are all mason stains that I've tested before. You see these colors? So obviously, I've got a bunch of blues. You can see they're all subtly different. And it must be the auto white balance that's causing these colors to not read very accurate. Here's a glaze, or here's a mason stain that I've got, and it's just like super duper powerful. It's this kind of turquoise. It's a Hummel mason stain, and I like it because just a tiny little bit goes really a long way. So I think we'll do a blue-green. Or should we? No. I always use blue glazes. I'll do something else. How about a chartreuse? Like lime green. But that too I've done before. What do we got? Roy G. Biv. Got red, orange, yellow. Praseodymium. That's yellow. Got 66, best black. Cerulean. Ooh, cerulean blue. I got this one too. This is a mason stain opacifier. I've never really tried this, but you're supposed to, this is basically like a white mason stain that you can add in to lighten the colors. So if you've got like a really strong deep red, you can supposedly add this mason stain to it and come up with a pink. Stuff is called Vitro Blue. We got a bunch of this. Bunch of other little samples. Ambrosia, coral. Tangerine, that's a great looking orange. Let's try some tangerine. Lobster. Oh, this is such a good red. I've used up most of that. What else we got? Got colorants too. All right, well, we're just gonna get on with it. So this is iron, and if I were to add iron, I'm probably gonna get in oxidation, I'll get like a black glaze. This is basically what I get with local rocks. I don't think I need to test iron because I can already get some really lovely iron glazes in my front yard, essentially. So I don't have to fool around with iron. Nickel is going to give me some darker colors. Cobalt is going to give me a whole bunch of blues. I could use chrome and get some kind of bright green colors. Why don't I try this? I'm intrigued by this chartreuse color. So let's try that baby out. Okay. We're just gonna start writing them down now. Get the yellows out of here. Got a ton of reds. Never really settled on like a really killer red glaze. So let's try and figure one out. Okay, we got orange. So let's do like 4 red glazes. We're gonna do one with rutile. Let's try rutile at 2% and this DR red at 4%. And then let's do one where we the red, and let's do like 10%. No, let's get crazy. Let's do 12% red. DR red. And how about I just start adding these instead of marking them down first? Let's walk and chew gum at the same time. Where's my small scale? There it is. I got this tiny little scale that's really good for small amounts. It does halves, grams, up to a tenth of a gram. So if I want like 4.5% or something, I can do that. How about a yellow? Red yellow? A red green gradient. Oh, that would be sweet. Pretty much limited to single colors. If I wanted to do like a red green gradient, I could do an overlap of 2 different glazes together. But unfortunately, glazes aren't necessarily like paint. They're not just like a 1-to-1. Can't mix them, and you really can't do kind of gradients between 2 wildly different colors. can. I could do, for example, you see this glaze combo. You see the white with the blue coming in between it. I could conceivably do a red over a green glaze and have like a red field with green little bubbles coming through it. There are ways to do that. What's going on with this glaze is essentially the underglaze has gas in it that bubbles up during the firing, and so the bottom glaze bubbles up through the outer glaze. And people call these an oil spot because it looks similar to an oil spot, and it's a similar kind of phenomena, but red yellow, that sounds good. That sounds like orange. We're gonna do an orange. Okay, and I need a little, here we go. So here's a glaze chemistry trick, a glaze lab trick. Show ya. I've got my little scale here. Don't need these anymore. So take a piece of paper and fold it in half. Right? And then put that on your scale, and then we're gonna tear the scale. Wow, can you believe that piece of paper weighs 1.2 grams? So let's do 5 grams of orange. 3.8. There we go. $5 grams on the money. So the reason I like to do this folded piece of paper is that then becomes a little scoop, or like a little channel, I guess. All right, so then we're also going to add a little bit of rutile. We want 3% rutile. And again, the rutile is going to opacify, and it's going to darken it a little bit. And so since I took 100 grams, multiplied it by 12, and then divided it out into the 12 cups, I've essentially got 100 grams of dry material in each one. So when I add my oxides, if I add 1 gram of oxide, that's like 1%. 5% is 5%, or 5 grams is 5%. Okay, so there's 3 grams. Then we're going to add that to our first cup. Okay, so what I was just saying there is that now that glaze has 5% orange and 3% rutile. And then I'm going to go through and add in all these colorants to all these base glazes. That's probably going to be all the time we have on stream. I don't think we'll have time to go through and mix them all and then apply them to all. We might save that for tomorrow. But I did want to put this part on stream and show you guys how there are parts of this process that are very systematic and very exact and very scientific, But then, like, choosing what colors I'm gonna do, I mean, that's all relative. It's just, what do I feel like? What do I want to see? How do I guess? Okay, 2%. This next one is gonna be an opacified red color. So I need 2% rutile. Okay, that's 2%. And then I need 4% red. So we're gonna go up to 6 grams. Ooh, that red is beautiful. Right. So then we've got an orange, and then we've got a red. Let's try this pink. Let's go mag pink. And I've used this before and it hasn't been so strong. So let's try 10% pink. And then 2% rutile. And hopefully it's like a bubble gum. Wouldn't that be sweet? So now I need 10 grams of this stuff. Sweet, that's like bubblegum cocaine. 10 grams on the money. And 2% rutile. So in other studio news, I got my small kiln working. So these bowls that we're making right now, they're going to be the maiden voyage, the maiden firing for my kiln. I was able to find an extension cord. Let's check out this extension cord. And that thing like freaking serious. Basically, the plug that came on that kiln was a 50 amp plug, even though it's not a 50 amp kiln. So it's got a different plug. And this one converts it down to a 30 amp, which is the plug that my dryer is. So I can plug the kiln into this one and then plug this into the receptacle. So it's going to save me some time, and it's not like I am exceeding the amperage of the plug. All right, back to the task at hand. Let's go with this little leaf green color. Let's just feel it out here. How much do we want to do? Call it 4 grams. Looks good, looks good. And then we'll do 4% green, and then we'll do 1% rutile. Do less opacity. Cool. 1%. And I always love looking inside glazes before the colors are all mixed in. See how they kind of are soaking in. Fix my camera a little bit so you can see what I'm pointing at. That red looks cool. And the green that we just added in. So these mason stains are gonna be what colors. The stuff we already mixed into the cups, that's just the glaze itself. That's the glass. Right, so in other words, these are all just generic sugar cookies, and this is like chocolate chips and walnuts and brownie bits and caramel. And that's what's going to give us our different flavors of cookies. If you feel me, if you're smelling what I'm cooking, if you're picking up what I'm laying down. Okay, we got a nice green. Let's try this blue green. And like I said, this Hummel blue green, I bought this like 10 years ago in Columbus, Ohio. And this was like a discount thing. They were getting rid of it. And I think I bought this for like 50 cents, and it's lasted me. I've mixed like 5-gallon buckets and colored it. I've colored multiple like 5-gallon buckets, and I made like casting slip. And that's a pretty sexy green right there. Turd Ferguson, I gotta get in on the cookie stream. I always think of Kevin from The Office. Cookie season. I forget what he says. So let's try 3% Hummel blue-green. And then let's do 2% rutile. Yeah. Okay, there's 3%. Nice, that looks good. And our rutile, which is kind of ugly. It looks like that rock is that color, pretty much. Brown town. Copper sulfate? No, this is a mason stain turd. And so basically, they probably arrived at this color by mixing copper and cobalt. Who knows how they got to it. It's a really strong colorant, so probably chrome and cobalt, if I had to guess. If I had to try and recreate it, I would use chrome and cobalt and titanium probably. Okay, 2%. Close enough to it. My scale shut off. That looks like a good 2%. Okay, orange, red, pink, green, blue, green. Let's try this purple. I know I said I've already got a purple, but let's try the purple. I'm feeling the purple. I'm inspired. I'm inspired by this bag that I bought. High index of refraction, that's cool. Dropping some mineralogy on us, Turd Ferguson. You got an index of optical refraction. Let's see. We want to pull out the introduction to mineralogy. Ooh, here we go. We got our periodic table of elements right there. Fundamental. What we're talking about though right now are these ingredients in particular. These are called the transition metals, right? Scandium, titanium, vanadium, chrome, manganese, iron, cobalt, nickel, copper, zinc, galena, silver, gold. These are all colorants. These end up being fluxes. These guys over here, and then these over here, well, silica ends up being the glass former. So I put in the title that we were going to get some chemistry going on in the stream. So there you go. There's your chemistry. Back to the purple. I got a disease and the only cure is more purple. Let's get after it with the purple too. Let's go 10%. %, purple. And let's get after it with the rutile too. Let's go 3% rutile. Let's up that refraction, baby. So if you think about it, with optical refraction, light waves are shining in to the ceramics. And when you've got a celadon glaze, kind of like this, that's really clear, light is going straight through. It's not refracting, right? The light waves are hitting the glaze and basically going straight through to the underlying clay and then bouncing back. Whereas if you've got a bunch of metals in there, right? You got some tin, titanium, minerals and materials that have a high index of refraction. The light waves are going in and they're scattering and they're bouncing, and you're getting all kinds of interference and opacity, right? So the light waves are bouncing back, and the light waves are hitting those molecules, and the wavelength is changing and reflecting back as color. which is pretty neat. Color field theory. Why is blue blue? I like to dip my toe into the world of science, and I like to be an amateur mineralogist and an amateur geologist. But then I like to come back to my world of pottery, where sometimes I can just get away with just mixing stuff together, just making it up. Like I don't have to know what I'm talking about. I could just do it sometimes. But then you do it, and then you like want to go figure out why you like it. And then you have to backtrack a little bit. All right, so those are the first 6 that we did, right? Show you. You got 6 of these babies, right? Those first 6, those are all going to be opacified. So those are going to be like modified. Now we're going to take the other 6 and we're just going to go straight ahead. And we're just going to do relatively high percentages of the glazes on each one. And the beauty of using this paper on our scale is that if it gets all stained with oxides, just throw it away and get a new one. When I'm mixing test glazes and I'm using iron and manganese and copper and cobalt, and I'm really doing a lot of these cups, I like using the paper so that I don't have to waste time cleaning things and drying things. All right, 10% orange. It's a lot of orange. Right, 10%. That should be a hot orange. Then we're gonna go dark red, which is another one I've got a lot of, and we're gonna go 12%. We're getting crazy on the red. Getting wild here. Getting wild at the Husky Ranch. All right. 12% wild. Now we've got 4 more that I haven't decided on. Let's see. Any of you 17 viewers have an idea? Want to pick a color? Shout one out. The number 12 spot is open to the next person. Let's do a pink again. And let's try another pink. Pink Pony approves. The Pink Pony approval. All right, let's try the pink. Let's try like 12% pink. Let's get the pink cocaine here. All right. Another pink. There it is. I was thinking we should do one with an opacified red. Like I pulled out that this is basically white, and so white plus red is pink. Ooh, nice. Got some more. Rain silent, debating pink or yellow. Yellow it is. Okay, Sin Pass. I think you had talked about doing a yellow earlier. And then we've got Fox Red Buddy wants a deep purple. Excellent. Okay, we'll do a deep purple. How about we do like a deep red? How about we go red plus purple? Nice. Or we could do a black and a purple. I've got some black mason stain. Or we could go a blue. I'm imagining deep purple with a blue. Yeah, let's do blue. All right, yellow. Yellow cello. So we did 12% pink. Now we're gonna do yellow. And I've got some canary. Canary yellow. We'll try that at 12% too. 12% is the move. There's something in there. Something that's not mason stain. Oh no, my scale turned off. Ramen, usually glazes can work like that. If you got two solid colors, sometimes they'll mix. I don't know. It's so hard though. I usually say in glaze classes to assume that they won't work until you test it and see. All right, there's our 12% yellow. In it goes. Now we're gonna do a deep purple. So then let's try one with, oh wow, big old chunk of purple. Okay, so that's 9% purple. And then we're gonna do 3% of blue. So we'll get a nice blue purple. A nice deep purple. And then for blue, where's my blue box? I don't see it. And I'm not going to go dig around, so we'll just use Vitro Blue. We're going 3%. All right, 3%. And last but not least, let's try another red. We'll do not that. Let's go purple and red. Let's try and get that Bing cherry. So 5% purple. And then we're gonna go with a different red. And that's looking good. That's looking like what I want. Well, that's a good question, Rain Silent. It's really not that hard. You can use a number of different ways to like mask off glaze and to apply colors. You can use stencils, and you can brush it. I will say it's pretty difficult to brush glaze and to get it consistent. It's super duper easy to brush it and just kind of get what you get, but to get a really controlled look, you really have to know what you're doing, and you have to be really careful with the brush. So that was 6%, and that one was, I'm gonna write a star on this one, 1351 red. All right, boys and girls. So this is looking pretty cool. I like that. Got our different colors mixed in. You can see our first one, the orange, is already like dissolved in. And then what's next, what I'm gonna do off stream, is to blend in all these colorants. And then I'm gonna pass all those colorants through the sieve, through the screen, right? Hey, what's up, Polyester Kit? You're just in time to see what we did on stream today, right? And we have our 12 colors that we're trying out. Our glaze recipe is in the top right. Okay, we're trying a cone 6 glaze recipe. And then we divided out that base recipe into 12 cups, and then we added colorants to these 12 different cups. There we go. I think we can see it. You guys get the idea. Okay. And so, with that, I'm hungry. So I am gonna call it there. What we'll do tomorrow is I will already have these mixed up. And then we're gonna glaze some pots, and then we're gonna do a maiden voyage in my little baby kiln. We're gonna get that baby fired up, and then we're gonna start to glaze some of the pots on our ware cart. See, I got all kinds of stuff over here. This ware cart is just like packed. Ton of stuff. I gotta start glazing. All right. Set that baby down. Yeah, it's all crooked. That's all right. That's all right. We're moving on. Tomorrow, let's see, do I have a schedule posted? A schedule? Oh man, I've been bad about scheduling. I'm gonna do, I don't know what time I'm gonna go tomorrow. We're talking about going and seeing a movie, which sounds good. I don't know. I don't know what time. Around this time, I would imagine. Let's call it 6 o'clock Alaskan. I don't know. Stay tuned. I'll post it tomorrow morning. So check in around noon tomorrow, your time. If you're in the East Coast, on the East Coast. Oh, Raman, I just saw your question of making a colored glaze. How well does making a colored slip using a clear glaze over it? That's a great way to go. Especially if you're interested in like doing some really detailed brushwork. That's the move for sure. It's a great way to go. But I just like having colored glazes. I like the glazes mingling and mixing with each other and melting and doing kind of crazy fun stuff. Yeah. All right, so I think that's all the questions. It's gonna be the usual time. The stream will be the usual time, and I'll have it posted on the schedule, and I'll follow the schedule. So, with that, we're gonna go raid. Who's out there? Who's out there doing stuff? Got a forger, a blacksmith, forging some stuff. Hey, there we are. The Glaze Chemistry and Testing Blue Potter with 17 viewers. Oh, you guys are awesome. Thank you so much. Tuning in. We're gonna go check in. Looks like somebody's doing lamp work with glass. Samson Glass. Let's go raid Samson Glass and check out Samson Glass. Oh, doesn't allow. Glass Lizard. Oh, I guess he does. Here we go. All right, guys. We're going to go raid Samson Glass. I'll be back on stream tomorrow where we'll put some glaze on some potteries. And I will hopefully see you then. Thank you all so much. Have a great night.